Today we're going to be talking about slope. Now, as I go through these notes, I would like for you to take notes on your own paper with me. So when we talk about slope, slope describes the steepness of lines in the coordinate plane. So think about like when we talk about a ski slope, we're talking about something like you're going down it, and so you're talking about a certain steepness of a hill. And so when we refer to slope, we're talking about the steepness of certain lines. Now to figure out what your slope is, and we use the variable n to represent that, we're going to find it by figuring out from one point to the next, what is the change in the y-coordinates over the change in the x-coordinates. Another way that we'll refer to that is as rise over run. Think the sun rises, so that would be like a vertical change, versus running, we run horizontally, so that would be how much it's changing horizontally. And we'll look at some examples of that later. Now we have four main types of slope. We have positive, negative, zero, and undefined. So a positive slope is something that's going to slant upward as we go left to right. So it would look kind of like this. A slope that's negative is going to go down as we go left to right. And we'll talk about exactly how you might get a positive or a negative number later. The next type of slope is zero, which means that you have a horizontal line. So maybe your graph might look kind of like this. Now the reason why that would give you a slope of zero is that remember that slope means the rise over run. So if I were to take 2 points on my graph, let's say these 2 points right here, 0, 3, and then 3, 3. To go from one point to the next, I'm not rising any. So if I think about rise over run, my rise would be 0. Even though I'm running, I'm changing horizontally 1, 2, 3. So 0 over 3 simplifies to 0. That's why a horizontal line is going to have a slope of 0. Now the next one is called undefined, and that would be for a vertical line. The reason why this might be undefined is because, say for instance, I take 2 points on my line. When I'm taking rise over run, I can see that I rise 1, 2, 3 while I don't change it all horizontally. So there's a run of 0. Now there's no way for me to divide by 0, and because of that we say that that slope is undefined because 3 divided by 0 does not exist. Now next what we're going to look at is finding the slope of different lines from a coordinate plane. So when I find slope from a coordinate plane, I'm always going to try to start with my point to the left, and I'm going to move to my point to the right. And I always like to make what's called a slope triangle to try to find my rise and my run. So since I'm finding rise over run, I'm going to start with finding rise. So I'm going to start at my first point and see how much I have to go up or down to get to my next point. Now if I go up, because that's in the positive direction, I know that my rise is positive. If I would have to go down, that would mean that my rise is negative. So I can see that to get to the next point, I have to go up 1, 2, which means I have a rise of 2. And then once I'm here, I have to go right 1, 2, 3 to get to my next point. So I'm really just saying if I can only go vertically and horizontally, how do I get to my next point? Well, I have to go up 2 and to the right 3, so my slope is 2 over 3. Now notice again that they're using m to represent slope. That's a variable that just represents slope, and you'll see this as we go throughout the topic. Okay, the second one, I'm going to do the same thing. So I'm going to start at my point to the left and figure out how far it is to the point to the right. So we start with our rise. So I'm going to go to get to the next point. I go up 1, 2, 3, so that's positive 3, and then I have to go to the right 1, 2, 3, 4, 5, so that's positive 5, which means that I have a slope of 3 over 5. Positive 3 because I'm going up, and positive 5 because I'm going to the right, and positive values are to the right on the x-axis. Now last but not least, we have a line that we can see is going to have a negative slope because it's going downward from left to right, and we'll see how that happens with these points. So first I'm going to find my rise. I can see that to get in line with the next point, I have to go down 1. Now since I'm going down, I'm going in the negative direction, so that means negative 1 for my rise, and then I go to the right 1, 2, 3, 4. Now going to the right, remember, is a positive value, so that's positive 4. But when I take negative 1 over 4, that's going to give me a slope of negative 1 over 4 like this. And so my slope is negative 1 over 4. Sometimes you will see your slope written this way. Sometimes you'll see it written this way. It doesn't necessarily matter where the negative is because those represent the same thing. Now for the next set that we're going to look at, we're going to be finding slope based on 2 points. Now, even though I could always graph these to find the slope, I don't always want to have to create a graph, plot my points, and then figure out what the slope is. And so another way to do that is just by calculating it. And so to do this, remember that before we said that to find our slope, it's the change in the y-coordinates over the change in the x-coordinates. Now to be able to find slope, then that means I need to find the difference in the y's and the difference in the x's. And so when we do that, we actually end up subtracting our y values on top and our x values on the bottom. Now if you notice what I just wrote here, this is going to be our slope formula that we use. To find slope, we're going to take y2 minus y1 over x2 minus x1. Now you might be wondering, what is the difference between y2 and y1, x2 and x1? Well, what we have to do is just choose one of our ordered pairs as x1, y1, and one of our ordered pairs is x2, y2. So we're just really distinguishing between our first ordered pairs and our second when we put that little subscript of 1 or subscript of 2. So we have x1, y1 for our first point, x2, y2 for our second point. And really it doesn't matter which one you call x1, y1, which one you call x2, y2. You'll end up getting the same answer in the end, but I'm just going to set it up this way. So on top, because we're finding our change in our y-coordinates, we want to take y2 minus y1. So my y2 is 4, minus y1 is 2, and then on the bottom I want to take x2 minus x1, so 2 minus negative 3. Now one important thing that we have to pay attention to is that our ordered pairs kind of line up together. So notice that your second ordered pair was 2 and 4. Those are right above each other, and then here the same thing happens with your first order pair, negative 3 and 2 kind of line up. Also notice again that the y's went on top and the x's go on the bottom. Think back to when we found unit rate, how we always did y divided by x. The same type of thing happens here when we find our slope. Unit rate is kind of like slope, except that slope can be used for non-proportional relationships too. So when I solve this, I'm taking 4 minus 2 to get 2. 2 minus negative 3, remember, keep out opposite. That's going to be the same as 2 plus 3 or 5. So I get a slope of 2 over 5. Next one, y2 minus y1 over x2 minus x1. I'm going to identify my first order pair as x1, y1. My second is x2, y2. And then I'm going to subtract. y2 minus y1 would be negative 5 minus 1. x2 minus x1, 8 minus 6. So I'm just plugging those numbers in. Negative 5 minus 1 gives me negative 6. 8 minus 6 gives me 2. And then notice here that I could simplify this to give me negative 3. Just like unit rate you could write as a whole number, with slope we can write it as a whole number also. So I'm going to write that as negative 3. So let's try one more example with our last example. Let's again just call our first ordered pair x1, y1. Our second order pair x2, y2. And then we subtract our y's on the top. We're taking the difference of the y values over the difference of the x values. And so this is the formula that we can use. y2 is 4. y1 is also 4. So on top we're taking 4 minus 4. On the bottom we're taking x2 minus x1, 1 minus negative 2. 4 minus 4 gives me 0. 1 minus negative 2, keep out opposite, is going to give me 3, so I get 0 over 3, and 0 divided by 3 gives me 0. So this is a slope of 0. So now let's look back at our answers real quick. Notice that a slope of 2/5, my very first one, that was a positive slope. Then I have a negative slope, and then I have a 0 slope, which would be a horizontal line. Next, what we're going to look at is slope in situations. So sometimes we also see slope in real life outside of on a coordinate plane. So the first part says, for number 5, it says the building code for a ramp recommends the ramp should rise no more than 1 inch for every 12 inches of length. And it says, does the ramp shown meet the building code? How do you know? So the first thing that we're going to do is try to find the slope of the ramp. We're going to try to find the slope recommended by the building code, and then we're just going to compare them. So this is honestly very similar to finding unit rate, to make sure that those ramps are proportional to one another. So notice first, so it says find the slope of the ramp. We're going to find the rise over run, or the vertical change over the horizontal change. Now my vertical change is 8 inches, or 8. My horizontal change is 70 inches. And then if I were to simplify that, I could make that 4 over 35. Now, with the recommended slope, notice that it says it should rise no more than 1 inch for every 12 inches of length. So my rise goes on top, 1. My run goes on the bottom, which is 12, and that's already simplified, 1 out of 12. Now notice here that because we have both of these in fractions, it might be kind of tricky to compare these numbers. And so sometimes, even though fractions are the best way to write slopes, sometimes it's nice to write those as decimals just to make it a little bit easier to understand. So I'm going to change 4 over 35 into a decimal, and when I divide that, that gives me about 0.11. Now the next one, when I take 1 divided by 12, that gives me 0.08. Now one thing to keep in mind with slope is that the steeper that it gets, the higher the number. If you think about it, if you flip back to the back side, horizontal slopes had a slope of 0 versus like when you get to a positive slope, you have an actual number. And so notice that as it's becoming more and more positive, that number is going to get bigger and bigger. So we can say here that our slope of 4 over 35 is steeper than the other slope. And so keep in mind here that with this problem, so this is the steeper slope, keep in mind that they said the recommendation is the highest that it could be. It says they recommend no more than 1 inch for every 12 inches of length. So we would say that no, this doesn't meet building code because it's too steep. So because the slope is too steep, it's not going to meet the building code. Okay, now next thing that we're going to do is compare unit rate to slope. So I said before that unit rate ends up being very similar to slope. So one thing to keep in mind is that a rate is a ratio that compares how one quantity changes as another changes, and the slope can be interpreted as a rate or a unit rate, which is a rate expressed as a quantity of 1. So what we're going to be doing is looking at our slope and then interpreting it as a unit rate. Now it's only going to, like anytime that you have a unit rate, remember that it's kind of like our y divided by x, and because this crosses through 0, 0, we're able to find our unit rate in the same way that we find our slope. So first thing we always want to do when we're finding our slope, notice here it says the graph shows the amount of milk used to make butter. How many pounds of butter can you make per gallon of milk? So we're trying to find butter per gallon of milk. And so first thing that we want to do is identify our 2 points on the line, and notice that gallons of milk is on our y-axis and pounds is on our x-axis, and so those are the numbers that if I was just finding unit rate, I would be dividing. Now in this case, we're going to find our slope. So we find our slope by the same way as we did before, finding our rise over run. So we're going to take y2 minus y1 over x2 minus x1. Or we can also use our graph and just find our rise over run. So if I make my slope triangle, I can see that I'm rising 5 and then I'm running 2, which means that my slope would be 5 over 2. And so when we write slope, a lot of times we're going to keep that as an improper fraction, but basically what that tells us is that we have 5 over 2, or 2.5 pounds of butter for 1 gallon of milk. Okay. Now I want you to go ahead and try the last 2 examples on your own. Try to figure it out. So notice with your first example that you were just finding your calories per minute. In this case, that's 88 divided by 8, or 11 calories per minute. Now in the second case, what you're doing first is you're going to be finding your slope to figure out how much she's repaying, and we find that